Good evening, everyone. My name is Jayan Pillai, and I'd like to welcome you back to another Tech Talk in our series sponsored by Seismic. Today, we have the pleasure of welcoming Ploynapa Yang to give us a brief talk about microservices. So without further ado, I'd like to pass it on over to you, Ploynapa.
Thanks, Jayan, for the warm welcoming. And hi, my name is Ploynapa Yang. Before we begin, I would like to start by thanking Seismic for sponsoring the Tech Talk. And thanks so much, everyone, to come out and join me tonight. Today, we are going to talk about microservice. To break that down, we'll go over monolithic architecture. What are microservices about? How do microservices work? Some examples, and a summary to wrap things up. But before we dive into the details, let me ask everyone a question. How many bank accounts do you have? You can raise your hand if you have more than one. Then why is that? Imagine having one or a single, all-encompassing bank account. All of your money is in one place. Every transaction affects the entire balance. If you want to increase your spending power, what do you have to do? You have to add more money into that single account? Well, it is straightforward and convenient, but it has its downsides. Any mistake could affect your entire financial standing. That's where the saying, don't put all of your eggs in one basket. Now, consider having multiple accounts. You might have separate accounts for different purposes, such as savings, bills, investment, entertainment, or so on. If you want to make a change to one of your accounts, does it affect the others? No, it does not, right? Each account operates independently, giving you more control and flexibility. This is called diversification or segregation of risk. These concepts mirror the different two schools of thought around system design and architecture. Traditionally, software developers build an applications using a monolithic architecture, where all components such as business logic, data access, databases, and user interfaces are tightly integrated into a single large unit. Initially, this design starts small, but can quickly snowball into a large cumbersome system. As the application grows, it becomes increasingly difficult to manage, evolve, and scale due to several limitations, such as complexity in development and management, single point of failure, any bugs or issues in one part can potentially bring down the entire system. Scaling challenges. Scaling a monolithic application is tough because all components must be scaled together, even if only one part needs this. These days, clear project planning with a set boundaries is key to manage this growth. When the project becomes too large and clunky, you have an option to branch out into microservices. Microservice is an architectural approach to develop software applications as a collection of small independent services. These services communicate with each other over a network. Unlike monolithic applications, where functionality is tightly integrated into a single code base, microservices break down the application into smaller, loosely coupled services. This approach allows for more flexibility in developing, deploying, and scaling each service independently. Now, let's break down the key concepts. First of all, decentralization, governance, and independent deployment. Each service operates independently and decides to handle a specific business function or feature. For example, one service may manage user authentication, while another handles product functions. Flexibility. Different technologies can be used for different services. This means that different programming languages or frameworks and databases can be chosen based on the specific requirements of each microservice. Each team will have the flexibility to use the best tool for their respective functions. Scalability. Services can be scaled independently, allowing for more efficient resource use. Updates or modifications to one service without affect the entire system, which leads to fault isolation. If one microservice experiences a failure, this does not always lead to a failure of the entire application. This promotes overall application resilience as many parts of an application remain available while the team works to restore the failing microservice. CI/CD, Microservices Architecture, demands a robust and efficient CI/CD pipeline to manage the deployment of numerous services. DevOps practice provide the necessary foundation for seamless integration and delivery by automating build processes, running tests, deploying microservices to production environments. And lastly, multi-layer security. Today's business applications need multi-layer security and real-time threat protection across all operations infrastructure and data centers. Fully managed development platforms offer the necessary level of integration and built-in security controls for this. How do they communicate? These microservices communicate with each other through application program interfaces, aka APIs, by using HTTP, gRPC, or messaging queues. From the middle of this diagram, what is an API gateway in the context of microservices architecture? An API gateway is a single entry point from which clients can access various microservices. It facilitates routing, authentication, load balancing, and catching of requests, simplifying the client-side experience and ensuring security and reliability in a microservices environment. Let's understand the microservices using the real-world example. Netflix is one of my favorite applications. Netflix started using microservices since 2009 and had over 1,000 microservices. These are responsible in keeping over 200 million users satisfied. The best part is they don't have to directly depend on other services for their functioning. Even one is down, the user barely noticed it. Let's see how they integrate in a huge platform. We are going to focus on some of our main components from this diagram. The left side of the diagram with the small lovely faces are clients, or could be you, or could be me. When you click on the show that you want to watch, your request is sent to the identity provider. It authenticates your request by identifying you as a regular user. These requests are passed into the API gateway, then forward the request to the appropriate microservices. The service environment is under management control, which balance services on nodes and identify failures. Each feature has its own working microservice. Handling their own database also have their own load balancer and execution environments to function properly. And each microservice has a handled by a small agile team. Netflix has a cloud-based infrastructure. I bet you guys can guess it. It is AWS. They help Netflix to run microservices, to store movies, to handle internet traffic, and most important of all, security. Another example that everyone knows this online shopping platform, Amazon. Amazon's online store is like a giant puzzle made of many specialized pieces. All these pieces are called microservices. Each service does a specific job to make sure every part runs smoothly and every one of them work together behind the scenes to give you a great shopping experience. There are more on the well-known companies that have successfully implemented on the microservices, such as Uber, X or Twitter, Spotify, eBay, or Coca-Cola. Lastly, you might be wondering which architecture is right for you. Does microservice suit your application? Keep in mind that microservices can solve a number of problems, but honestly, microservice is not for every business. Adopting microservices can incur overhead costs. It is not too bad to start your application design with a monolithic architecture and consider microservices as your needs grow. Perhaps the best example is the two-pizza rule from Jeff Bezos. Says a team in charge of microservices should be as big as the number of people you can feed with 2 pizzas. So hire a few people that eat a lot, or if you have the budget for it, a lot of people that eat very little. Now, I would like to open the floor for our questions. If you have no questions, here are my contact info. And here's my work site. And again, I would like to thank Seismic for sponsoring this TikTok and everyone here for the wonderful support. And I'm passing back to Jaeyoung.
Thank you for that informative talk, Ploy-Napa, and thank you everyone for coming out tonight. We'll see you at the next one.